Good morning. It's what, Thursday morning. The week is going by quickly. So, I need to set up all of my chat stuff over here so I can actually see what I'm looking at. Miguel, good morning. I have chat up on my phone right now. And Anand P00033, good morning. Look over here, dashboard, and pop out chat. I have I have actually thought about an interesting, like a few little interesting, I don't know if like IoT would be the proper projects for it, but a little mini devices maybe run by Raspberry Pis where I can like put them around the house and it would be, they would just sort of like have one or two tasks that they do, and that's kind of it. Sort of like functional IoT projects. And one of them has, in my mind, has been like a Twitch chat, where basically it could just sit like right here next to my computer and display the chat and nothing else. Good morning, your average dork. Never mind the screen name, but still, good morning. Glad you're here. All right, so I can close you now, save my phone battery life. All right, so, and I need to increase the brightness of this screen so I actually see. Having Twitch chat around the house sounds like a very bad idea. I think I only want to keep it here, like right next to the space where it's the place where I'm actually doing the streaming. I don't actually come down here very often except when I'm streaming. Like this room has kind of become a dedicated sort of studio room for that. So because of that, I think I actually could get away with it. Let's take a look at, sort of remind ourselves what we had gotten into last time, which was we had created a randomly covered circle that's just a that's just the outline of it, so it's a line filled, and it spawns a bullet as soon as the program starts, and it fires it off into a random direction. But the way it's choosing the random directions, it chooses a target, a specific spot somewhere in the entire map, and then it gets the difference between that, and then sort of that at that point just goes. Then it fires it towards that, but because it uses subtraction between the two vectors, what ends up happening is it the speed changes. So Camel and Hat, good morning. IoT projects are a lot of fun. The small LCDs for Pis could work, but could quickly add to clutter. Yeah, so that's the only potential like problem that I would have with it. But on the other hand, I would like to get a larger desk, so that would be something I could fill up the desk with. The other potential thing is I wouldn't need this like big computer so close and visible. I could have this farther away if I wanted to. Because all it's doing then is just streaming, and then I could just have a little tiny device for the chat. I don't know. There's a lot of possibilities here, but what I wanted to do today was change this so that the bullets fire at the exact same rate, regardless of whether or not they aim here or way over here. And hey, TR Pap, good morning. One of the biggest so. The reason why this is happening, and this, it might be confusing to some people who haven't like looked into this before. When I subtract the coordinates of here and here, it sort of magically gives, like, tells it to to have the bullet travel towards that direction. Well, what's happening is it's just getting X and Y. So like every frame, what X and Y should it move in order to then reach there. So I'm getting the left and the right like that. That's what I'm getting, is this part of the triangle, or in this case, like that. And what I need to do is something called normalization. So I need to reduce the distance, the angle, to 1. And how I know this and how I figured it out is a long time ago on this stream, actually. Although it might not have been this stream, it might have been when I was experimenting streaming on YouTube. I actually bought Nature of Code, which is the book by Daniel Schiffman of the coding train, and I actually have that here with me now. And I went through a decent part of the book, like maybe halfway through the book, so. And there's a lot of angles and variants and other things, and one of them was this normalization thing and how to get the bullet essentially to fire at the same pace throughout. Yeah, you need to fix bullet speed, and then clip once it's outside of the bounds of the window. Yeah, so it's clipping. It's basically turning off as soon as it gets outside of the window. So what my plan is to do normalization. So let's see if I could find the chapter for this. I was looking at this last night because I had to find it after moving into this house. Vectors, normalizing vectors. Also, in case you want to check out this book, because I believe it's a truly fantastic book, what is it? Nature of Code book, Schiffman. Is it 2 F's or 1 F? 2 F's. So if you come here, you could actually just read the entire book for free online, or you could pay whatever you feel like for him. So I believe I paid the standard amount, and just did like whatever he wanted, whatever he recommended. To actually, and that wasn't the ebook. I think I actually went to Amazon and bought the physical book, just because I wanted to have it. So if you go to read now, what we're at is in the vectors section, and this is going to be 1.5. So let's go down to 1.5. Where are we now? 1.7, so it's a little bit too much. Okay, so we want to go to normalizing vectors. So in here, it talks about you want to make it the same, you want to keep the same direction, change its length to 1, and that way, without regard to its length, that you can now scale it up to whatever speed you want, and it'll be the same speed regardless of what that, whatever the original length was. And the thing here is, it's the exact same speed because we're going to reduce it to 1 and then multiply it by 500 in our case. So what we need is the length right here. What we have are these parts of the triangle, and of course, there's maybe an easy way to get that, but what we really need is the magnitude. So it actually describes in here that if you have the magnitude, then all you need to do is just divide the entire vector by the magnitude. Okay, so let's find out the magnitude, which just happens to be the section right before that. So the magnitude is really just the length. So it's this. Now, the idea of why you divide by the magnitude is because if you want to get 1 out of something, convert something to 1, just divide it by itself. So this is where I wish I had I had another whiteboard, but I can maybe use the, can I use the book as it? Sort of not really, because it's square and I need a triangle. All right, so we could use this triangle here. If we want to normalize it, this is what we want to reduce to 1. We don't have it, but if we had it, we just divide it by the same amount and it would reduce to 1, because that's how math works. These things would then, we divide them by the same magnitude here to keep the ratio the same, and so they would be less than 1. They'd be a decimal, a float between 0 and 1. And we do the same thing for this here. We have these two, and we remember from high school math that if we have 2 parts of a triangle, we can get the third pretty easily. So of course there's Pythagoras. Is that the right pronunciation? We have that theorem. So we're going to take x squared plus y squared, and that will equal, I guess it's a and b. I was going to say like z squared. That doesn't seem right. We're going to get x and y, square them, add them together. We're going to get this length. Then we're going to divide. Yes, math. And then, but there's actually an easier way, which is just take the square root of x squared plus y squared. Well, I mean, square root is essentially undoing the squaredness. More like boo math. Well, so in my mind, this is the reason why you have reference books around, so that when you realize, oh, I need math, you go look up what the math you need is. Either that or know somebody who knows math. After I looked this up last night, my wife was a little bit disappointed that I didn't go to her first and ask her, because she is a math person, and so she would have been able to tell me exactly what I needed to do. But instead I relied upon the book and Daniel Schiffman, and so she asked me next time. All right, so I don't want to right now look to see, because I was also told there's a vector 2 potentially on one of you mentioned, I can't remember who, that there's a vector 2 off of GGEZ sort of type that we can use. I don't want to look into it right this second, because I want to implement this myself. And once we implement this, then we can go and take a look at it, and it would take a lot of the math that we have in their application out, because we'll just be able to run functions like normalize and add and subtract. All right, so we'll need the magnitude, and then we'll get that. So let's implement that first. So back to the code, go into main, and so this is going to be in the bullet. So in the bullet, we're going to want to get, so function get magnitude. This is going to take just a reference to self, because it's going to return a number. And I don't think we're going to need any. Do we need anything else? Oh, so you know what's interesting is we're going to get this from fire, because we're going to get the location and the target. We need to get the magnitude of this direction. That's what we need. So we're going to take a direction, or maybe we'll just call this like a vector, which is going to be type .2. And we're going to return I guess this is going to be a floating point number, so an F32. So what we'll do is we'll return the square root. So I actually haven't used square root in Rust before. I wonder what Wonder what library it's off of, or if it's just like there for us. Okay, so Rustlang square root. There's F64. Squirt, SQRT. That's probably good. Yeah, that's a good one. That's usually how they call it, isn't it? Stack Overflow. F64, I don't care. Jump to SQRT. Okay, so public function square root take that and return an F64, but this is off of the primitive x64. So I wonder, is there one off of F32s? So F32, is there a square root? It should be in here. This is something that bothers me a lot. I wish that these were organized by alphabetized, because like ATAN, if I was looking for ATAN, I might have given up way back there. And it makes it a little bit harder for me to actually look through, because I was kind of not reading any of these to begin with. I have to read really carefully. There it is. Square root. Okay, so we basically just public function square root takes in self, so we can take the number and then dot square root. You looked at it, but apparently it's all from the N algebra library, both vector2 and point2. We could take a look at the library after we get the bullet firing in the same speed. I can do Control F to find it. I guess like the problem sometimes is if it's not spelled the exact way that we expect it to, that won't work either. I don't know. I just sort of have feelings about documentation and organizing things. I like them to be organized in that way. Okay, so use standard, and I think that these are put in here in the order that they're actually implemented in the code. I think that's what I was told of how it is. Yeah, I wonder if that's something that would be relatively easy to do, or that I could do if I know enough. All right, so we could just do positive. So square root is, yeah, so we could just run it off of the number itself. So what this is going to be is we first need to get the x squared plus y squared, which we have that with the vector. So we're going to return I guess we could do this in two lines to begin with, right? So we're going to say C, like the magnitude. Well, I guess like magnitude normalization is dividing by 1. The magnitude is just the square. Okay, the square root of that. So I want the double magnitude. I'm not sure what magnitude squared. So magnitude squared equals, it's going to be vector dot x times, can I do like times? Because I could just do vector dot x plus, and I'm going to want to probably parentheses these to make sure that they're really around each other, just in case. Vector dot y plus, times vector dot y. All right, so that will give us the magnitude squared. Let's just be happy that Mozilla finally controls the Rust documentation. Well, I mean, it's true. Mozilla's documentation for everything else they have is really easy to change. It's pretty much either a wiki or hosted like on GitHub or someplace like that. Yeah, I could probably just do it myself. I think what I would want to do is implement these as traits. And then we can put those traits on whatever types we end up wanting to be. So that way it's a little bit easier to do this. So now it's probably yelling at me because we haven't actually returned an F32 yet. So now we just want to square the result of this. So that would be the magnitude squared dot sqr. Okay, let's try that. Yes, so that works. You also have standard num sqrt. Oh, really? So if I come up to the top, sqrt. That's what we got. So off of the numbers, still off of the numbers. This is interesting. Return a new vector with the square root of each of the values. I bet it's a vector and not what I want, but maybe it is. Have I thought about writing your game with actors? I saw an awesome video of a SimCity type game written in Rust using actors, and it was really impressive. So I have to admit, I don't really know what actors are. I saw it referenced in the example code in GGEZ, so like I know they exist, but I haven't looked into like what they are really. So maybe, is it just that they're simple like objects that we insert in, or is it like there's an actual actor type out there that I can use? Well, here's the thing. I don't know if they're implementing in whatever way that like everybody else uses actors. I just know that I saw somebody in the example code. In fact, that print was not what I wanted. If I go to GitHub, GGEZ, examples, Astroblasto, in here, now we define our actors. So there's reference to actors in here. So I don't know. I guess that's the thing, is like there's probably more to it, but maybe not, and I just don't know enough to know one way or not. It's a paradigm, like object-oriented versus functional. So is it like a third paradigm? It might be interesting to look into. All right, so what we were looking for was num. So standard num. See, I wish that it was standard cell pin. It should be right before pin. Standard num wrapping. Okay, I need to. Standard num. Whoa. Num. That doesn't like that. So wait, you can't find this. So if I do standard num sqrt. Huh. So let's go to standard num and find out what it does. Is there an sqrt here? I don't see it. Yeah, I don't know. I'm not seeing anything on num like this. Maybe the documentation is just being too esoteric for me. So, I don't know. Looks like they took it out. You got sent an old link and now, okay, so it's probably removed then. It's probably a trait that's been added to all the number types and it's just a generic. So it takes in any type of number and then returns it appropriately. Okay, so I want to I like this, doing this instead of a single line, because I can't call squared itself or square root itself. I would have to essentially wrap this in and then do dot square root on it. I don't want to have to deal with that. So let's just do it like this. And then we want to also have a normalize function. So function normalize, this is going to take a referent. Do I even need, so I don't technically need self at all. It's just ignored right now. Do I need, so might as well be self. I'm not going to affect anything. I'm going to take in a vector and, well, okay, so I think what I'm going to do is I'm going to take in a vector, I'm going to normalize it by passing it to get that magnitude back, and then divide by it. So we're going to take in a vector, which is a 0.2. And we're going to return another 0.2. But now it's normalized to maximum 1. So any one of the points in it? No, the length would be 1, but the x and a y would be different. You just looked at the version of the docs, it's pre 1. Oh, that's a long time ago. All right, so in here, what we want to do is we want to just divide by that. But the book does remind us that if we have a length of 1, so if we have any zeros, we're screwed. It actually says in here, in Nature of Code, that when we're getting the magnitude, or maybe it's normalization. One small issue. What if the magnitude of the vector is 0? We can't divide by 0. So we have to make sure that the magnitude is not 0 before we're doing that. Okay, so we first get the magnitude. So let magnitude equals, and we're going to do self dot get magnitude and pass it the vector. Then we need to make sure, so if the magnitude is greater than 0, so if the magnitude is greater than 0, okay, so if the magnitude is greater than 0, but I kind of wonder, should we like throw errors at this point if we can't do that? Or should it just be like a panic? I don't know. If the vector is 0, it doesn't exist. Well, I think what the thing is, what if, yeah, the length is 0. Well, the length can be 0. So here, let's bring up what we have right here. If the length is 0, that means it chose the exact same spot that the center of the circle is in. It's targeting itself. So yes, Crossbow, you actually got that exact same time that I was. So yeah, it's possible that it can, in which case we don't want to do that at all. It's already normalized essentially because it's less than 1. So we don't want to do anything at all. But with normalize, okay, so if the magnitude is greater than 0, then we want to, what is it? We want to then divide the vector by magnitude, But of course, in order to do this, we're going to return a point 2. We're going to turn a new point 2 where the x is going to be vector.x divided by the magnitude, and the vector dot y divided by the magnitude. And that's it. But of course, we're going to run into a problem here because it's Rust. We can't return null. We can't not return something. Ambiguous association type. Oh, I need to say what type, isn't it? Point 32 F32. So that's what it is here. There. I need to tell it what type I'm returning. Expected structure, point, found Boolean. Oh, it's... I wonder, do I even need this? If I'm telling it what type here, will it figure it out here? And the answer is ambiguous associated type. No. Okay. So I think it's right here. F32, like that. It's thinking about it. Nope. Let's see. Wrong number of type arguments, expected 0, found 1. I think, is this where I need like ... to tell it what type it's going to be? No, okay, so it doesn't like that either. All right, so we're going to return a point 2. Have we've returned a point 2 just on its own before, right? Point 2 : F32 : new. That also seems pretty crazy, but we could try it. Maybe return is point 2 F32. Well, I've tried that before too. Of course, like what I could do is just say this. Let result. Let's just try this right now. Let result. We're gonna sort of set that to be right here, and we're gonna say result is gonna be equal to a point 2 : new. Oh wait, structure. This is supposed to be parentheses. That's the problem I have. Now, here is a fun part, and this is where Rust is going to yell at us. I can't just say return result, because what results isn't necessarily going to be what I want. Can't find, let's see. Well, mismatch types, that's 0.0. And so now it's saying return a possibly uninitialized variable result. We're going to have to use the option type. So we're finally gonna, for real, use the game result here. So let's do game result, and we're either going to return a point 2, or we're going to have to return a game error. Do we have an error? A point 2 like that. Which means here we're going to wrap So I don't need result anymore. What I want to do is wrap this in an OK. So OK, like you, like that. So this is returning the OK. It may be, if maybe missing an else clause, which it is here. So else. Otherwise, we want to return a none. Well, let me do that. Is it none like that? Not a function. Okay, expected, found enum variant none. Okay, so I don't want to do that. Let's keep the none in the church. Right, I just need a, it's a sum or a none. I think what I expected enum result found enum standard option. Oh yeah, you know what? I want to do an option so I can do a sum. So that's it's not a game result. It's going to be an option. An option, I think that means I think now I do a point to. It's been a while since we've returned an option. And so now this is going to be a sum that we return here, or a none. That's it. So now I can actually, we can use normalize, and if we get something back, we know we've normalized it. And if we haven't gotten something back, we know we did not normalize it. This is like one of the first times that we've actually used option, the option type itself, instead of just creating our own enums. And I think it works out well here. Okay, so magnitude. So get magnitude is used here, but I think it's upset because we're not using normalize. So now what we want to do is use normalize inside of fire. So we're going to get the direction, but before we set the velocity to the direction, we're going to have to now normalize that. So let's, we could shadow the direction, or we could override it. Let's set this to be mutable. And then right here, we could do, okay, direction equals self dot normalize, and we're going to pass it in the direction. But we have to actually get this out. So I think it's an if let, right? If let self normalize direction. Can't I do dot? It's doing because I want to be able to do self normalize so that it passes in. I guess I don't really care if it's that. Why are you upset? So expected one of : equals pipe . All right. Why do you work and you don't? Or maybe it doesn't work. I've used self here before, right? To fire off one of these other ones. Yeah, self is off screen. I think maybe it's my if let. It doesn't let me do that in here. Okay, do I need to match off of it? So match self.normalize, pass it the direction. And then we'll have the match arms in here. Or was it simply because I didn't have the semicolon in, and then there was that upset? Okay, hold on. Let me try this again. So direction equals if let self dot normalize, we pass it the direction, and then semicolon. No, so it doesn't like that. Either that or I just forgot how if let works, which is a more likely thing. So Rustlang if let. So let optional equals sum. We can match like that. If let is cleaner for this use case because we only care about one thing. Oh, so it's if let sum I equals the number that was sum, then we do something with it. Okay. So I was just using if let wrong. Can I do? Yeah, okay. I have no clue what if let is, left to right. That drives me crazy. All right, so let's just try this again completely, starting from here. So we're gonna say if let sum, and it's going to be a point, I guess. A point equals. And it's going to be the self dot normalize, and we're going to pass it the direction. And then, according to this, if let, we now have our brackets, and we put the code that we want to have in there. So inside of here, now we're going to say direction is going to be equal to point. There, and now it works. I keep on using match, but in this case there was only one option. Like if it doesn't happen, I don't want to reassign direction. I want to keep it as it is. Otherwise, we do this. So I think this is a perfect use of if let here. All right, so then we have that. Now let's scale up. So before we set the velocity direction, we're now going to scale up by multiplying. And I'm wondering if maybe what we want to do is scale up by a certain amount. Well, I mean, obviously we do. So direction is mutable. This is good here because we're about to say direction dot x equals direction dot x times 500. It's a magic number, but I think that's because we never said speed up here. So we would need to, like our velocity is speed, we would want, because this is going to be reset now, we would want to now have like a speed, and then we're going to scale by that way. We also probably want a, we would also normally want to have a scale function off of this so that we could just scale that up easily. It's kind of like a ternary operation, confusing at first, but enforces a mindset towards programming. Yeah, I think it does. I really like so one thing that I dislike, so I want to say like one thing I dislike about if let, it didn't allow me to assign something to this. And that makes me really sad. The reason why it makes me really sad is because in a normal if statement in Rust, I can actually return from the if statement into the thing that I'm doing. And that is beautiful functional programming. This feels a little bit less. I feel like a match would be more functional. but maybe there's a way to do if-let that I don't know. All right, what was I doing? So direction x equals direction x times 500. I want to do the same thing. Oh, I want to do 500 F32 to, like, instead of doing the dot zero all the time. And then direction dot y equals direction. Wait, can I do times equals? I think I can. Times equals. Times equals 500 F32. Okay, that's a little bit easier. Obviously, it'd be nicer if I could just do direction times equals 500 F32, because then that would, but I would need to, like, do some fun stuff to that. All right, so then velocity will be equal to direction. Let's save this. Everything should now be the exact same speed, unlike this. So let's come back to here, run it again, and hopefully we should all have scaled up bullets. It feels to me that they're all going the same speed now. So I think we did it. All right, so let's move this over here. And one thing we wanted to look at was to go to the documentation for GGEZ. So let's go. I always end up just going to creates.io and looking for the document, like getting the documentation from here. So GGEZ. So we have 10 minutes left. Let's go take a look at what we can find on point 2 and vector. Documentation. All right, so we want, let's first start with point 2. Okay, so GGEZ graphics point 2. I guess there's not really much, right? Yeah, so it's N algebra point 2 F32. Then there is this type vector 2, which is off of N algebra vector 2. Oh, and they have a matrix for 3D stuff too. I guess they have a rect, which is okay. So then how they're doing this. So it's just really public type, which is off of these types. So they're just sort of forwarding it on. Well, so what that really means is we need to go to N algebra. N algebra. Can I get there from here? Is there an easy way to get there? So links. Oh, dependencies. So we want NA. N algebra. So we'll go here. So we're at the specific version that we're using. Also, I want to move this to the left, a little bit more to the left, so that way we could see the game thing on the right, because it's cool. Okay, so we have N algebra. We now want in here to look at point 2 to begin with. Oh, interesting. Look, they have points all the way to 0.6, but GGEZ is only letting us use up 0.2. So trait implementations. So we have, not sure easy how to read this. Multiply? Is that what that is? Result after applying the times operator. So they have multiply. So they have the times operator. Was that it? They didn't implement plus. They didn't implement addition. That's kind of actually fascinating that they would implement multiplication but not addition. How are they? This is a real number. Real number. How are they doing that? Okay, so implement. Oh, I'm not familiar with like the $ stuff. Oh, it's macro. That's why. I haven't really played with macros very much. All right, let's see. So implement, live, real, storage bound. Okay, we have to make this a little bit bigger. Oh, this is dense. So where the default allocator is allocator M. Operation is left hand, right hand, I think? Is that how I'm reading it right? This feels complex operation implementation. This is a little bit tougher to read in the 5 to 10 minutes that I have. Oh, maybe 0.2 is an alias? You could be right. Let's go try that out. So come back here. We can go to point. Interesting. Why is it a different color? So this is a different color than one it has it otherwise. Dense code is best code. All right. Field. So the coordinate. So it's just a single thing. I don't see any of the algebra stuff. But maybe, oh, this is methods. We'd want traits. So trait implementations. There's sub, it's for subtract. Okay, so they have sub, add assign. So for example, if we want add, so implementation for this, where scalar, okay. Here's the add vector. I don't know why this is highlighted when this is the one I wanted. So scalar plus close add. Output the point that's just adding it. But of course, adding a single point adding a single point is pretty easy. It's just a number plus another number. It gets a little bit more difficult when we're talking about like 0.2 and so. But yeah, I can totally see that. Let's also go take a look while we have in the last couple minutes. Vector 2. So vector this. So NAlgebra core vector 2. Oh, and I guess I want to look at I want to go back to, okay. Creates.io, GGEZ. documentation. I want to make sure which one we're taking off of. So it's going to be vector 2, or maybe just vector. Do we have, okay, it's this one. Vector 2, let's go take a look at the source. Vector 2 is NA vector 2. Okay, so it's just straight off of NA vector 2. So vector 2. It must be this one right here. Type vector 2, a generic, takes a vector 2 of the type and a U2. So that doesn't really, I guess, help with that. Traits, scalar, and slice range. Huh. So is this... Am I correct in saying there's almost no traits for a vector 2? I'm not sure if I'm reading the documentation correctly for this. But if that's so, then yeah, it probably is exactly what we want. We probably do want to use vectors, but then we're going to have to implement traits for the add assign, and then implement that ourselves. So at that point, I'm not really sure what benefit we're getting from using like the vectors and not just creating our own. Anyways, that might be something to sort of think about in the future. But what I want to do, because I set up my I set up all the code things last night, is I want to close and save this so I don't miss anything. And we're going to push up. What do we do? Bullet is fired at the same speed now. And I'm going to push that. Yes, don't show that again. And let's go find mine. What? Okay, hold on. Unlock. Did it do it or did it not write it correctly? Sure. All right, so that's yours. Let's go to mine. I really am sad that like the most recent one that I've worked on is no longer up here. It's like harder for me to find what I just did. I'm gonna have to go to my profile. Here it is. And bullet is fired at the same speed now, so we'll take this and let's put this into chat. All right, so if you want to go find that code, you can. I've got that all set up in here. You'll need Rust. The latest version of Rust is fine. If you want to play around with it, we've got it so that the circle comes into the center here and then chooses a random target location anywhere on the screen and then fires a bullet at it, but they're now firing all at the same speed regardless of how close or far away that enemy is. So we're going to be able to get into some maybe bot type stuff soon. We may have to clean it up shortly. I don't know. I don't know how much more this test repo is going to get us, but that'll be next time. I've got to go get ready for the rest of my day, and then I will be back. Whoa, tomorrow is Friday. Wow. Here's a good video when you get the time. What is this video? Is it for actors? I'm gonna save that over here. Type safe and high perf distributed actor system in Rust. Ooh, that'll be fun to look at. Right. I also lost my dashboard chat. There you are. So I'll save that off to the side. Thank you, TR Pap. Let's see. There was a lot more chat that I missed today, which is pretty awesome. I like it when you guys are able to chat and have fun. With that, I am going to switch over to the ending stream. As I've sort of mentioned in the past, I don't know exactly what I'm going to do for timing continuing on. I'm missing the first bus that would like get me there in a good, like, nice and early to work. Arrives like in 1 minute, so I'm obviously gonna miss that. My next bus I have to walk like 15 minutes to go get, so I may want to start streaming a little bit earlier so I can take the bus into work. But if I do anything, I will, I'll talk about it here, and I'll also tweet about that. So with that, I'm gonna take off, and I'll see you all tomorrow morning.